Hello, Algebra 2. This is a lecture on finding probabilities of independent and dependent events. This is section 10.5. In 10.5, the goal of 10.5 is to answer questions like this. So hypothetically, we have a bowl of purple and green grapes. What is the probability of us randomly selecting two consecutive green grapes? So this is a little bit different than section 10.4. 10.4 was one selection, and we were looking at multiple characteristics of that one selection. 10.5 is going to be looking at probabilities when we are doing two actions, selecting two items. It would be very common for a section 10.5 question. We do have a little bit of vocab. We have independent and dependent events. Two events are independent if the outcome of the first event has no effect on the outcome of the second event. Things that would be independent events would be things like flipping a coin or spinning a wheel, where regardless of what happened in the first outcome, it doesn't affect the likelihood of that outcome happening again. Dependent events, on the other hand, would be events where whatever happened the first draw changes the likelihood of that same event happening again. So drawing a card from a deck would often be a dependent event as long as you still have that card in your hand, because it changes the likelihood of other events happening because you have one of those in your hand. You've removed one from the deck. So there's going to be different ideas that you're going to have to think about if you're finding independent or dependent events. So it's important that you're going to be able to tell the difference between them. If we are dealing with independent events, and you want to know the likelihood, the probability of both events happening, that would be probability of A and B. So if A was, some event occurring, flipping a coin and getting heads, and then event B was rolling a dice and rolling a 2, for example. The probability that A happens and B happens would be whatever the probability of A is. So if I said flipping a coin and getting heads, that would be a 1/2 probability. And then if event B is rolling a dice and getting a 2, that would be a 1 out of 6 probability. And you would just multiply those and you would get 1 out of 12. So if I want to know the probability of flipping a coin and getting heads and then rolling a dice and getting a 2, 1 out of every 12 times that should happen. Now, if the two events are dependent events, we are still going to take whatever the probability of A is, but then we're going to multiply that by the probability of, and then there's this weird notation that this is going to be the first time that you've ever seen it. That notation is going to read the probability of B, and then this symbol means essentially given that A occurred. So this notation is asking you to assume that A happened. Now tell me what the probability of B is. Probability of B given A, assume A happened. What's probability of B? That's what this notation means. So let's go ahead and take a look at some examples. Find the missing probability. This is just going to be using our formula. I can tell you right now that this is an independent event because it gave you A and B, but this one would have been a dependent event because the notation has changed to part of our dependent formula. So remember, the formula is the probability of A and B is equal to whatever the probability of A is times the probability of B. I can just fill in these things. 0.3 goes here, 0.21 goes here. That's my unknown. I'm just going to take 0.3 and multiply that by 0.21. What I end up with is 0.063. Like I said, the second example is just going to be a dependent event. It doesn't necessarily explicitly say it, but we know because it's using this notation that it is going to be a dependent event. Probability of A and B is equal to the probability of A times the probability of B given A. So I'm going to fill this in. We know probability of B given A is 0.41 and probability of A is 0.83. We're just going to multiply those two things to arrive at our answer. 0.83 times 0.41 is 0.34. This last example, it's not really more difficult. We just kind of have to solve for an x because this is our unknown. That's the thing that we're trying to solve for. It's going to use the same formula, but it's going to be 0.48 is going to equal 0.6 times x. Just solve for x, so divide both sides by 0.6. 0.48 divided by 0.6 is 0.8. So probability of B given A is 0.8. What about just identifying if something is dependent or dependent? This example says you have 48 grapes in a bowl. Of the 48 grapes, 30 are purple and 18 are green. What is the probability of drawing a green grape followed by a green grape? Would this be a dependent event or an independent event? And hopefully you guys are agreeing with me that this is definitely a dependent event. The reason for that is because once we have selected a green grape, then the likelihood of us selecting another green grape or even a purple grape has changed. We are less likely to draw another green grape and more likely to draw a purple grape. When it comes to grapes or even a deck of cards, I could ask questions that are independent probability or dependent probability using this kind of language here, with replacement or without replacement. What I'm saying is, if you put that card back in the deck, shuffle, randomly draw again, that would be with replacement. Without replacement would be I'm still holding that card. So with replacement would be independent events, and without replacement would be dependent events. So you're going to have some that deal with decks of cards. Find the probability of drawing a spade and then a club. So first we're doing with replacement. So we can just find the probability of A selecting a club. We know that there are 13 clubs in a deck and 52 total cards. We replace that card that we drew, and so we just randomly say, hey, what's the probability of us drawing a club? Well, that would be 13 out of 52. And we can multiply these, making sure we reduce our fractions and get 1 out of 16. What about without replacement? So in this example, you would first say, what is the probability of event A? And event A is drawing a spade. There is still a 13 out of 52, or 1/4 chance of drawing a spade. But then you would multiply that. Remember, the formula is probability of A times the probability of B, given that A happened. So what we need to do is we need to assume that A happened. We need to assume that I drew a spade. Now, what's the probability of drawing a club? Well, if we think about what's left in the deck, there are still 13 clubs left in the deck, but now there are only 51 total cards. So this is going to be the probability of drawing a spade and then a club if you don't replace it. So 13 out of 52 times 13 out of 51. When we type that into our calculator and turn that back into a fraction, we're going to get 13 out of 204. Let's do another round of this. Still drawing 2 consecutive cards with a deck in a deck. Why don't you guys go ahead and try to answer these questions? Great time to pause, give it a try. With replacement, just what is the probability of drawing a face card and then an ace? There are 12 total face cards in the deck and 52 total cards. You place that face card that you drew back in the deck, and then you randomly draw another card. What is the probability that you would get an ace? Well, there are 4 aces in a deck, and you're just going to multiply these things. 12 out of 52 times 4 out of 52. And then turning that into a fraction, we're going to get 3 out of 169. What about without replacement? The probability, of course, is going to change. This is now a dependent event. The probability of A times the probability of B, given that A occurred. Probability of A is 12 out of 52 still. But now we need to say, hey, what is the probability of drawing an ace if you assume that you already drew a face card? What is the probability of drawing an ace, assuming that you drew a face card already? Well, there are still 4 aces in the deck, and now there are only 51 cards. So you're doing 12 out of 51 times, 12 out of 52 times 4 out of 51. Turning that into a fraction, you're going to get 4 out of every 221 opportunities. You should get a face card and then an ace. So that's what I have for you guys for section 10.5 on independent and dependent events. I'm going to clarify a couple of things in another lecture on section 10.5, but if you guys have any questions, please let me know.